Hello, everyone. My name is Aldo, and I want to tell you about my paper, Hospital Surgical Services Design Improvement Using Business Process Reengineering and Relational Database Approaches. So this is a paper of mine and Muhammad Dahyar. So surgical services play a big role for health patients. Surgical service is one of hospital services. About 28 until 32% of the total disease in the world is the condition of patients who need surgery. So it shows a very large demand of surgical services in hospital. The source is from German Global Surgery Association 2018. But the negligence in the operating room is still done. Surgery is an important action for the patient's recovery, but there are several examples of negligence in the hospital operating room, including surgery on the wrong patient or incorrect procedures, and even surgical instrument left in the patient's body. Surgical safety checklists as a standard of surgical service to maintain patient safety and prevent negligence. But there are some facts about improper SSC filling. One hospital in Yogyakarta, only 9 per 13 general surgery operations and 8 per 12 oxygen surgeries that count post-operative instruments. In US hospitals, SSC completion was 85%, but the accuracy is poor, which is 54%. The surgical team did not use SSC properly. Hospital in Surabaya in 2012 only used SSC of 33.9% with an average completeness of filling just 57.3%. So there are some factors that cause SSC is not done properly. First is unprepared because they are still working on other things. And the second is they are not remembered to fill in the SSC. So the SSC basically launched by the World Health Organization in 2009. So the purpose of this research is to design improvement of the surgery services using BBR approach and relational database information system to improve service process time or efficiency and reduce the risk because doctors and nurses forget to fill the SSC. The methodology is basically there are 4 steps. The first is the early research stage, which I select the topic, make the background, the study literature, formulate the problem, and determine the research objectives. The second step is the SS model design analysis. So I'm study the surgical service process in public hospital, and then I process observation and conduct an interview with experts, then model the process with software. And then I make the simulation of the SS process and validate the simulation with the expert. The next is analyze the efficiencies and risks in the as-is model. After that, next to the step 3, to be model design, there I'm designing the proposed surgical service model, create entity relationship diagrams, create a data flow diagram, designing several to-be process models, and perform a simulation. So after that, the final research stage is comparison of as-is and to-be process results, analysis of simulation results, and making conclusions and suggestions. So after I make observation in the hospital and asking and make interview to some experts, I make this model in iGraph. After that, I run the simulations. So this is the surgical service as process, the main process, and there are some sub-process. There are sign in, time out, and sign out. So this is the sub-process. So I run the simulation, and this is the result. After I make the model and run the simulation, I see some problem that occur to the process, and after that, I also ask for some experts what is the main problem they usually face in the operating room. So this is the list of the problem, and also I asking the experts and interview the experts about what goal that they are want to achieve, and from the goal and the problem, I make this some solutions, and from 5 solutions, I make classifications. The first classifications is parallelism. So the solution is perform administration in parallel to reduce waiting time. So basically, in this hospital administrations, usually done in series. So where well, actually the hospital have 2 administrator, but sometimes one of them is idle. So the next classification is information system. This includes 3 solutions. First is filling out form using devices, where the filling time recorded in real time and confirmed according to the SOP. Then using relational database. The third is the instrument search is done by using a database system, and there are single instruments outside the package. And the last is real-time counting of tools and consumables is done using RFID technology. So the real-time counting of tools and consumables is done using RF technology is the classification for RFID. For the goal and the problem, you can see in this presentation. So for the information systems, the information systems itself consists of 2 steps. The first is entity relationship diagram. So this is the entity relationship diagrams where ERD functions is to design the structure and relationship of each data in the surgical services that is designed. And then after I make the entity relationship diagram, I make data flow diagram. So DFD or data flow diagram states from where or who the information comes and sent, and to where or whom the information is needed to be stored and accessed. So this is the context diagram, and this is the DFD level 0 of surgical services. So basically they are for notes. The first is manage user accounts, the second is patient registration, the third is surgical preparation, and the fourth is surgery. And there are some actors. There first is surgical administration, second is pharmacy, the third is RFID tech, the fourth is nurse, the fifth is doctor, and the sixth is human resource divisions. And for the connections of the nodes and the actor and the database, you can see on the presentation. So the surgical services improvement, I make the surgical service improvement into some scenarios. The first scenario is a parallelism, and the second scenario is information system, and the third scenario is the RFID technology. And there are some combinations, basically 3 combination scenarios based on the 3 classification mentioned before. They are the 4th scenario, 5th scenario, and 6th scenario. For the 4th scenario is parallel and the combination of parallelism and information system. For the 5th scenario is combination of parallelism and RFID technology, and the 6th scenario is a combination of the 3 classifications. So it is the most complete. And this is the total the main process of the hospital surgical services. This for the 6th scenario, the original process are indicated by 1 line for shapes border. Like for the example is the first task, the surgical admin accepts the surgery agreement and patient data is the original processes, and the processes whose duration were reduced are indicated by double line border. So for this example is the ninth task, which is surgical admins provide information related to surgery and scheduling to the surgical team. And the omitted process are indicated by triple line border. For the omitted process, you can see in the sub process. Here the sub process. So the omitted process, for example, is the task 23.3. Make sure the surgery and anesthesia approval letter has been approved. So basically, if we use information system, we don't need approval because it's automatically done in the information system. So after I make the model, the 2B model, I run the simulation, and here are the results of the simulation. I also ran the 6 scenarios. So this is the comparison of as is model time to with to be model uh, for each scenario. So for the first scenario is the efficiency is 10%. The second scenario the efficiency is 12%. The third scenario is 4%. And for the fourth scenario is 22%. For the fifth scenario is 15%, and for the sixth scenario, which is the most complete um, solution, the efficiency is 26%. The sixth scenario is the solution with the most benefits and greatest efficiency, which is 26% of the total time of the surgical services. So the conclusion, this research proved that the method combination in BPR between information system and RFID technology achieved the research goal. The proposed improvement in surgical services is divided into 6 scenarios that can be selected by the hospital based on various factors such as financial and human resource readiness. The sixth scenario consists of the first scenario using parallel solution, the second scenario using information system, the third is RFID technology, the fourth is combination parallel and information system, the fifth scenario is a combination of parallel and RFID, and the sixth is the combination of the three classification of the most complete. The the third conclusion is the scenario with the least reduction in time is the third scenario with a decrease in overall time efficiency of 4%. The most complete and best scenario is the sixth scenario with a total efficiency of 26%. So for the fourth conclusion is this research gives suggestion to surgical team to improve the process of counting instruments and the process of sign in to sign out in central surgery. Okay, thank you. And this is my reference.